Today we're going to be talking about redshift and blueshift. Essentially, light is made out of different wavelengths. Each wavelength in our eyes turns into a different color that we see. Red color light wavelengths are at one end of the spectrum because they have the largest wavelengths and the smallest frequencies, versus indigo colored lights or blue colored lights, which have the smallest wavelengths and largest frequencies. Redshift is when the wavelength of light starts to increase, turning it red. Blueshift is when the wavelength of light starts to decrease, turning it blue. There are three main causes of this change in frequency. The first is the Doppler effect. Essentially, the Doppler effect shows that if a source of waves is moving, the oscillations it produces in its direction of movement will have a higher frequency or be closer together than the oscillations it produces that's not in its direction of movement or the opposite direction of movement, which they will have a lower frequency and basically they'll be farther apart. So redshift will occur if the source of light is moving away from us, and blueshift if the source of light is moving towards us. This type of redshift and blueshift can be seen in our theoretical diagrams of black holes. The second cause of redshift is, well, obviously Einstein had something to do with it, gravity. He theorized that light traveling out of a gravitational well would experience a loss of energy, so this light would lose frequency and therefore experience redshift. The opposite occurs for when light travels into a gravitational well. It gains energy, increases its frequency, and therefore experiencing blueshift. Consider that there is a wheel with a point on it. When the wheel spins, the point goes up and down. As we draw the path of it, it looks like a wave. Consider that the wheel does not lose energy while spinning. Now, let's do the simulation. When the wheel goes downhill, gravity pulls on it, so it goes downhill much faster, spinning faster as well, making itself complete a rotation more often, increasing its frequency. When it goes uphill, however, the gravity is still pulling on it, so it spins slower, making it complete a rotation lesser often, decreasing the frequency. That's basically how gravitational redshift and blueshift work. The final cause of redshift is cosmological expansion, called Cosmological Redshift. Essentially, the Big Bang, which is the most widely believed theory of the beginning of the universe, is said to have started from an infinitely dense point in space, containing all the energy and the matter of the universe. It exploded and continues to expand till this day. It is, however, said that it's not the universe that is expanding, but space-time itself. This expansion of space-time affects the waves moving through it. So when the light waves are moving through the space-time and the space-time expands, it stretches the light waves as well, thus increasing the wavelength and causing redshift. Absorption spectra, with the help of redshift, help us to see that the universe is expanding. These are the wavelengths of light represented in colors. When visible light travels through a medium, some of these wavelengths are absorbed by molecules in the medium, thus giving us an absorption spectra like this. When we see the absorption spectra of the sun per se, it would look something like this, with multiple black lines in the middle. Then, if we took the absorption spectra of a distant galaxy, you can see that the black lines seem to have maintained the same pattern, but moved towards the red side. However, do note that these conclusions are made with the assumption that all the stars in the universe have the same composition as our sun, that is mostly hydrogen and helium. This is proof that redshift is occurring, and therefore that the universe is expanding. Anyways, that's it for this video. Bye nerds.